Okay, I'm going to be going over the Istep free response practice thing we had to do last week during Pride. So the first says we're going to use this graph to try to answer the question 1. Part A says, does the graph show a positive or negative correlation? Basically, when you're looking at the graph, does the data go up or does the data go down? So in this case, the data pretty much goes up, so that means it's a positive correlation. And what does this mean with respect to the graph? So if we look along the x-axis, it's talking about the weeks, and then the y-axis is talking about the paychecks. So basically what that means is your paycheck is increasing the more you work. Now, sometimes it may ask you about a strong or a weak correlation, so since these points are pretty close together on this, and they almost form a line already, it'd be a strong correlation, so just keep that in mind. Part B says, give the point of the outlier. So outlier, we're talking about a point on this graph that doesn't fit, basically. So in this case, this point up here doesn't really fit with the rest of those points. So the point would be 18, and then in between 160 and 170, so about 18 and then 165. Now your answer may varied just a little bit, but it should be pretty close to that. So what does it mean for a point to be an outlier? So again, basically it's a point that doesn't fit or go with the data. Okay, the last part says, is it a linear or non-linear correlation? Again, linear means it would create a straight line, or pretty close to a straight line. So again, if we look back up here, it's almost a straight line, so it is a linear correlation. Then it says, use the graph to approximate how many weeks they would have to work to make $130 on their paycheck. So if you used a straight edge of some sort and put it at 130, then we're looking at this point right here, and if you go down, that's in between the 4 and the 6 weeks, so about 5 weeks would take care of that. Now the next page is about analyzing solutions and see if they're correct or not, and see if you can figure out what they did right or wrong. So it says the following two students were asked to solve the equation 4 times 2x minus 3 minus 5x minus 4 equals 29. Now, the way I always like to start these problems is by basically just doing the problem and then seeing where your mistake or where your work, see if it matches up with theirs or not. So what I would probably have done is, so we have 4 times 2x minus 3 minus 5 times x minus 4 equals 29. So again, the first step is to distribute. So we'd have 8x, 4 times negative 3 is negative 12. Negative 5 times x is negative 5x. Negative 5 times negative 4 is positive 20 equals 29. Then I would look at their steps. So Jill has 8x minus 12 minus 5x minus 20, where we have 8x minus 12 minus 5x plus 20. So what she didn't do when she did negative 5 times negative 4, she didn't make that a positive 20. So if you were to write out what was Jill's mistake, so first off, Jill didn't solve the problem correctly, and her mistake could be in step 1, she distributed the negative 5 wrong when she took negative 5 times negative 4 and got negative 20. instead of positive 20. So now let's look at the next person. So Jack had that step right. So let's look here. If we go back to our step, we know we distribute. Then we combine like terms. So 8x and negative 5x is 3x. Negative 12 and positive 20 is positive 8. So if we go down here, we can see what Jack had 13x plus 8 equals 29. So we got to look and figure out, okay, how did he get 13x instead of 3x, which is correct? So what he did, instead of taking 8x and negative 5x and combining them, he added the 5x to the 8x. So he did the opposite. So something to the effect of when combining like terms in step 2, he added 8x and 5x instead of 8x and negative 5x. So in other words, he should have had 3x plus 8 equals 29 instead of the 13x plus 8 equals 29. Okay, number 3 deals with a system of equations. So it says Pam went to the store to get some playground toys for her school. She bought 5 footballs, 3 soccer balls for $84. Henry also went to the store and he bought 2 footballs, 9 soccer balls for $96. So using this information, answer the following. So part A says define variables and write a system of equations that could be used to find the cost of each football and soccer ball. So the variables could be, we could let x equal the price of each football and y equal the price of each soccer ball. So my equations, since she bought 5 footballs and 3 soccer balls, so 5x plus 3y equals 84. Henry bought 2 footballs, so 2x and 9 soccer balls for $96. Part B says solve the system from Part A to find the cost of each football and soccer ball. So if we take the system, so 5x plus 3y equals 84, 2x plus 9y equals 96. So again, we want to use elimination here, so we want to try to get opposites in front of the same variable. So since 3 goes into 9, if I made this a negative 9y, then it would cancel. So I could actually multiply the top only, in this case, by negative 3. Now there are other ways to do this. So if I multiply that by negative 3, I get negative 15x minus 9y equals negative 252. The bottom equation would stay the same. So now that I have opposites, I can add these together, which would give me negative 13x. The y's would drop out, equals negative 156. And if you divide both sides by negative 13, you get x equals 12. So x again was the price of each football. So we know the footballs are $12. To find the soccer balls, we can pick one of these equations and plug in 12. So if I took the top equation, 5x plus 3y equals 84, and I plug in 12 for x, 5 times 12 is 60. Subtract 60, get 3y equals 24. Divide by 3, you get y equals 8. So the soccer balls then cost $8. Part C says Julie thought the school could use 1 more football and 3 more soccer balls. If the price is the same as above, then how much did she spend explain how you got your answer. So again, it is pretty simple. We know the footballs were $12, soccer balls were $8, so if we want to buy one more football and 3 more soccer balls. So you could say something like, well, one football would be $12, and 3 soccer balls would be 3 times 8, which is 24. So then we would add the $12 and the $24 to get $36. And again, when you're explaining, it's okay to write out the mathematical equation. You don't have to use words completely. Okay, the last page reviews different types of factoring. So part A says factor 24x to the 4th y squared minus 30x to the 5th y. So if we look at the greatest common factor, the greatest common factor of 24 and 30 is 6. This one has x to the 4th, this one has x to the 5th, so x to the 4th would be the biggest they both have. Y squared and y, so y is the biggest y they have. And if I take out a factor of 6 from 24, I get 4. If I take out x to the 4th, those are gone. If I take out 1y, minus, take out a factor of 6 from 30, we get 5. Take out 4 of the x's, you're left with 1. And then that 1 already cancels. Part B, if we look at 5, 10, and 75, they do have a greatest common factor that you can take out. We can take out a factor of 5, which will leave us with x squared minus 2x minus 15. Then we can try to factor what's on the inside. Some people use the diamond method, some people product sum game. So I always do the diamond method, so a times c on top, so 1 times negative 15 is negative 15. B is negative 2. So the two numbers that multiply to get the top and add to get the bottom are negative 5 and 3. So we have x minus 5, x plus 3, and then I can bring this 5 that we took out back down in front. Part C, factor 4x squared minus 49. Some of you may recognize it as a difference of squares. If not, we can still do the diamond. A times C would be negative 196. 0 on the bottom because there's no middle. And that's 14 and negative 14. So we can have x plus 14, x minus 14. The thing is, we have an a value here of 4. So we have to divide each of these by 4. We have to reduce first, so this would be x plus 7 over 2, x minus 7 over 2. Since it doesn't divide evenly, we take the denominator and put it out front. So we'd have 2x plus 7, 2x minus 7.